Hey guys, in this tutorial I'm going to show you how to solve free convection example. In this example, we want to find temperature distribution inside the room. In this room there is no forced convection and free convection is the main mechanism for heat transfer. It has four walls: floor, right wall, top, and left wall. Right wall and floor are isolated, and left wall and top are having a convection with outside. We also have a heater providing heat flux inside the room, resulting in temperature distribution inside the room. So let's start. First, we read our mesh. So we're going to find read mesh, and we choose our mesh. And this is our mesh. Let's check the quality. So minimum volume is positive, so everything is fine and we can start the simulation. As you all know, gravity is driven force for free convection heat transfer, so we need to enable gravity. And in this study, gravity is in minus y direction. Also, since we have heat transfer in our model, we need to enable energy. So we're going to energy and enable energy equation. So the next step is going to the material. So our fluid is air, and in order to consider the free convection in our simulation, we need to change the density from constant to Bosnisk. And for value, we put the previous constant value, which was 1.225. And we only need to add one thing, and this is the thermal expansion coefficient. As you can see in the file, the thermal expansion coefficient is equal to 0.0033. So 0.0033. We're going to change it. So next step is our solid material, and as said in file, all walls are made of wood. So we need to add wood material to our library. So we're going to solid, fluent database, change it to solid, and we're going to copy the wood. So we're going to the cell zone condition. For the surface body, which is interior of our numerical domain, we need to change the type from solid to the fluid. And we're going to make sure that our material is air. Next step is boundary condition. Our floor is isolated, which means that there is no heat flux. So we're going to thermal tab. We're using heat flux thermal condition, and for the value of heat flux we're using 0. For the wall thickness we're using 1 centimeter, and for the material we change it to the wood. Heater is providing constant heat flux of 10 watts per square meter. So we're going to the thermal condition, and for the value of heat flux we put 10, and for the wall thickness also the same as previous one, and for the material we're using wood. Left wall is having convection with outside, so for thermal condition we're using convection, and for heat transfer coefficient, as mentioned in the file, the value is 5. So we're using 5 for heat transfer coefficient. And the free stream temperature is 273. The wall thickness is 0.01 meter, and for the material we're using wood. Right wall is also isolated like floor. So we're going to thermal heat velocity is equal to 0 for wall thickness. We're using 0.01 meter, and for the material we're using wood. And finally, top wall. Top wall having a convection with outside, like the left wall. And for condition, we're using heat transfer coefficient of 5, pre-estimated temperature of 273, wall thickness of 1 centimeter, and material of wood. Now all the boundary condition is set. For solution method, solution controls, and monitors, we're gonna use the default value. And for initialization, we're gonna set all the parameters to 0 except for temperature, which is gonna use the 300 temperature. For calculation, we're gonna solve the model for 1000 iteration. So we change the number of iteration to 1000 and then we calculate. Now our calculation is complete. Let's look at the results. So we're going to the contour, and first we're going to start with contour of temperature. As expected, the air near heater is warm, and free convection helps the circulation of the warmth inside the domain. To have a better understanding of circulation, let's take you have to look at the path lines. So we're going to choose the interior. For the steps, we're going to choose 50, and for the escape, we're going to choose 25. And we are using pulse mode. As you can see, the circulation resulting from free convection distribute the warm air inside all domain. So this is the end of the tutorial, and thank you so much for watching.